Same standard that we've pretty much been on all week, selling SP2. Somebody read it to me. Good job. All week we've been talking about samples. Can somebody tell us about samples?
You got representative and bias samples.
What's the difference between the two, Kennedy?
A bias sample is like only like a group of people, and a random sample is fair.
Good job. So a random sample is fair. Everyone get a chance of being selected. Bias sample is only for a specific group, meaning some are excluded. Great job. Several vocabulary activities pretty much just gave it to us. Some other small things to remember. A sample is the smaller section. The population is everybody. So if you ever have a question asking you what's the entire group is the population. Kenny gave us a great explanation of the difference between a representative sample and a bias sample. All right, our practice is in this normal place. Let me see if I can go find it. Y'all may have already pulled it up. See if I got one in here. Let me just pull this one up. No, I don't like when they want me to open it and all this other stuff because I hate all this other stuff. All right, we made it?
Yes.
All right. Question one, read. A movie theater randomly samples the types of admission tickets sold on a Friday in the afternoon and evening. The results are shown in the table. Amelia predicts that when 400 tickets are sold on a Friday afternoon, it can be expected that 80 other tickets sold would be adult tickets. Stefan predicts that when 400 tickets are sold on a Friday evening, it could be expected that 100 tickets sold will be senior tickets. And then they want us to figure out is either student correct. First of all, let's look at what they gave us. How many total people is up top? Give us the total of adults. Give us the total of seniors. Huh? I can't hear you, baby.
There's 57 adults.
57 adults?
52.
Jamal and Jamaya, good morning. You're in the wrong place. That's why I clearly said check your email. But you can stay for the day.
Other class won't let me in.
Say what?
The other class won't let me in.
Well, that don't mean come to mail. You're supposed to came to me probably last day. But you can stay here for now because you ain't had mail today. All right, how many seniors we got? 63. All right, let's get the total of how many total in the afternoon and how many total in the evening. Good job. So we got 60 total, afternoon and evening, then we got to break down the results and see. So Amelia said if 400 tickets are sold, it could be expected that 80 of those tickets will be adults. 80 of those tickets will be adults. So let's look at our adults. 59. Add that with 63 so we can figure out how many total we had up there. 122. 59 out of 123. Or was she specific? She was specific. Scratch that. She said in the Friday what? Afternoon. So we only need to look at the Friday afternoon. So that would be 12 adults out of how many total in the afternoon? 12 out of 60. They then said if 400 tickets are sold, so if 400 represent a numerator or a denominator, it'll go at the bottom, but that'll be a total. So now we need to find an equivalent fraction and see if we're gonna get 80. So 60 times what is 400? Do we bring our calculators? This math lab? She got hers up here. Who did bring you some? You need some. 6.66 multiply that by 12. You got what? 80 on the dot? No, ma'am, you didn't. You had 79 point something. So when we say 1,000,000 is correct or incorrect? Correct.
Correct.
All right, before we even write anything, let's see about the funds. The fund said when 400 tickets are sold on a Friday evening, so where do we need to look? In the evening. Friday evening, he said 100 tickets sold would be senior tickets. How many senior tickets on Friday evening?
15.
So that would have been 15 out of the 60. He said we're selling a total of how many? All right, we already got that equivalent is 6.67. So go ahead and multiply that by 15.
You said 6.7 or 6.6?
6.67.
100.
100.5. So that'll pretty much be about 100. Is it true or false? True.
True.
So then they asked us, is either student correct? What will we say? All right, they said explain. Both students are correct. Because what? What can we say? How do we know that they're correct? Should okay?
Oh, I was thinking about
I took the sample given and made an equivalent fraction with the totals provided. And I got the values that they said will be sold. And of course, if you're not the one that showed pictures of your work, make sure you're able to show those fractions. 12 out of 60 equal to 80 out of 400. 15 out of 60 equal to 100 out of 400. If I saw you lose points on your fractions, I'm a math teacher. I don't need an answer. I need to see your thought process. Any questions around?
I'm still writing, Miss Kim.
All right, let me know when you finish.
I'm finished.
All right, anybody else?
I'm done now.
All right, question 2. Look like I had a part B to it, so I'm gonna try to make it fit. All right, somebody that can see it, can you read for it?
As Jordan says, $1,000 or more in calculate to get the number of units. One color of number is he is allowed to take 4 random samples of 200 numbers, and his results are shown in the text.
Good job. So he got a jar that has 1,000 total marbles, but his small sample only had how many? 200. So that means each of these totals will be 200. And that's what we're gonna use to help rationalize. A is a choose all question. Answer choice A said the total number of red marbles in the jar is approximately 168. Red marbles. So I'm trying to figure out how many red up here.
Yeah, it's right. It's 168.
But that ain't the jar. This is the sample. This is the sample. 168 and all of those together would be 800. So if I go and I get that total jar of 1,000, Cedric, you think that's still gonna be 168?
No.
Nope.
No.
All right. B said there are likely more blue marbles in the jar than any other color. What you know about those blue values?
That number bigger than the rest of them.
They bigger than the rest of them. So can we say that it'd be more blue than anything else?
Yes.
Yeah.
Yeah.
All right. C says there are probably more white marbles than green marbles. White, green. Take your head. Is that more white?
No.
36.
Oh, what you know about the numbers between the two, the white and the green?
Green bigger than white.
D said the number of green marbles is approximately 21% to 33% of the marbles in the jar. Let's see. Looking up top, look at our smallest green. Which is the smallest green? 42. We know that sample would have had 200 total. Somebody give us that percentage. Or what's the decimal? If we can't get a percent, what's the decimal? Now, how do I go from a decimal to a percent? I can't hear you, baby. You can put it over 100, or in other words, I'm gonna shift 2 times. 21%. All right, which is the largest green? All right. Do that out of the 200.
.33.
Good job. So that'll be 33%. So would you say D would be true or false? Yeah, that'll be true. If it was these percentages in the samples, then we could pretty much say it'll be about that many in the entire group. All right, E says the ratio of red marbles in the jar to the number of green marbles in the jar is most likely greater than the ratio of white marbles to blue marbles. Well, let's do the ratio. They first said red to green. How many total red did we have? We said 168. How many total green did we have? All right, go ahead and get that decimal value. 161 divided by 221.
.76.
Okay. And then they said the ratio of white to blue. What's the total of white? And then give us the total of blue. One what?
36. 200.
200 even? Mm, 45?
260.
Alright, get out.
.49.
So would you say A is true or false? They said the top would be greater than what we got at the bottom. Was that true? Yeah. It said B. All right, part D says, Omar uses the information in the table and the following steps to estimate the number of blue marbles in the jar. They said he considered the smallest ratio of blue marbles, which was 58/200. He considered the largest ratio of blue marbles, which was 82/200. He estimates that there are most likely between 580 and 820 blue marbles in the jar. Is his estimate reasonable? Now, I already gave us a smaller estimate. How many total marbles in this jar?
200.
That's in the sample. That's all blue.
1,000.
So we're gonna take both of these values. We're gonna get a equivalent fraction with 1,000 to see if we get the values that he said. What I got? 200 times what is 1,000? 2 times what is 10? So that means you need to multiply by 5.
200.
And then, did you do the other one? 14. All right. He said there'd be between 580 and 820. Is he reasonable? No.
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 And how do I know he's not reasonable? He is not reasonable because the values I got are 290 and 410. And Zala said they add together to get 580. The other rationale, 580 is more than half of the total 1,000, correct?
Yes.
So then I have to ask myself, half of 200 is what? 100. And those of blue were as close to 100 for us to say that we'll have more than half of that bag being blue. So we can rationalize with that as well. Any questions about it? All right, you still getting something? All right, 3. Somebody that can see it, can you read it to us?
Tammy was running for the class president. She wanted to know if she had a good chance of winning the election, so she decided to have her friends to help her complete the survey. Jonathan served as a random sample of 10 students from the school. 7 of them said they were both for 10. There were 230 students in the school, and all of them voted what a Jonathan said estimated the number of students who would vote for 10.
Good job. So we got a sample of 10 students, and of that 10 students, 7 said they would vote for 10. And now we got a total of 230 students, and they want us to figure out how many of those students will vote for 10. What do we need to do? How many in the sample voted for?
7,
Out of how many?
10.
And that ain't telling me my total is what? Once again, equivalent fractions. So 10 times what would be 230?
160.
Alyssa, you said something. What? 33?
23.
It sounds like you.
Okay.
161.
I thought you were only one right. 151. So, what can we say? How can we word it?
150.
Say what? Josh, 7 times 23, 150. Good. All right, so look at what the question was. They said, so if all of them vote, what is Jonathan's best estimate of the number of students who will vote for Tammy? What can we say?
161.
Then just pretty much tell what we know. The best estimate, she said, will be about 160. And then we do the because with it. We did our 17th, and then we multiplied that by 230 to get us 161. Or you could say you made an equivalent fraction with 17 and 230 to get 161. Either or. Any questions about it? Okay, let me know you think. All right, anybody else? Hey, what's that on your hand? Bracelet? All right, we're gonna try to make it at least through 4 and 5. Somebody read number 4 to us. All right, so they did a survey with 30 people. 24 people voted for Tammy this time. They say, what is Kimberly's best estimate of total students who will vote for Tammy? What we need to do? We already know how many total students in this school. What's the last problem tell us? It was 230. So now we got another person who did another survey. And from this survey, they got 24 out of 30 students that will vote for. Find the decimal bit. We can make equivalent fractions or we can change to a decimal multiplier. So I'm sure you take me. Y'all got decimal?
Sure.
All right. So then we would take that 0.8 and multiply that by 230. All right, so what can we say? Kimberly's best estimate would be about how many people voted for? All right, they said estimates, so I'm around it to about 180. What's all because? Come, Makia. I think that was you. So two ways, we can set up that equivalent fraction, which someone find it easiest to do since that's a pretty learning skill, or we can remember to change to a decimal and multiply. Either or. Any questions about it? All right, let's go on now. Got it? Let's see if we can make it through 5. All right, 5 is a true false. A representative sample of 60 students from a high school is surveyed. Each student is asked which elective he or she is taking. The table shows their response. All right, A says there are many excellent dancers at the school. Would you say that's true or false?
False.
Why you say false?
You don't know everybody excellent dancers at school.
Rationalize with the data that they gave you. Why you say true?
But Dan got the most.
Dan's got most of the students. So I would probably say true. A lot of students say dance. Now, whether they excellent or not, I guess that'll be up to us to decide if they excellent, but yeah. All right, B says about 25% of the students at the high school are taking off. Why you say true? 15 times 25? 15 is half of 25? All right. Now, how many did they tell us was in this sample up top?
60 students.
60 students. Who all chose are?
15.
15.
What you got?
4.
60 divided by 15 is 4. But 15 divided by 60 is 4. Probably 1 4.
25.
Not 25, probably 0.25. Yes. Now I can say this 25%. So make sure we're able to prove what we're talking about. That's why they want you to use the data. All right, C says in a group of 30 students, it is expected that 11 of them would take photography. How many take photography now? Out of how many? 11 out of 60. Down here they said now I got 30 students. So if I have 30 students, am I still gonna have 11 taking photography?
No.
No. All right, D said next year, 7 out of every 60 students will be taking music. How many people take music now? Out of how many?
60.
So if we have 60 next year, we can pretty much say the same thing? Yes. And then E states, in a group of 120 students, it is expected that 16 of the students are taking electronics. How many taking electronics now?
8 out of
8 out of how many? Now they told me I got how many? 60 times what is 120?
2.
And 8 times 2? So would that be true or false? True. Any questions about it? So whatever they ask us, make sure we're able to use the data that they give us to prove it. If we can't prove it, don't try to choose an answer that you aren't sure of. Any questions about it?
Ma'am.
That is number 5. How many total in that problem set? 10?
9.
9? So you got one more. They gave you a dot plot. Want you to do some comparisons. Got some box plots. Some more dot plots. And then a question. Okay. And 10 told you could take a snippet of your work. I don't be concerned about you being able to type in it. You able to get your work and take a picture of it. I take that. I prefer that over looking at what you're typing. All right, those of you at home, y'all have a good one. See if I can get out of here.
See you later. Have a good day.
Y'all got any questions? Just let me know.